Imagine, if you will, the scene of a bustling city street. Cars whizzing by, cyclists pedaling hard, even a skateboarder or two. Each of these moving objects, from the smallest skateboard to the largest truck, possesses something we call kinetic energy. It's the energy that an object has because of its motion. And it's not just in city streets, it's everywhere around us, in every move we make and every action we take. So how does kinetic energy work? Picture a ball rolling down a hill. As the ball picks up speed, it also picks up kinetic energy. The faster it moves, the more kinetic energy it has. But it's not just about speed. The weight of the object also plays a role. A heavier ball rolling at the same speed as a lighter one will have more kinetic energy because it's harder to stop. This is why a truck barreling down the highway has a lot more kinetic energy than a skateboarder cruising along the sidewalk. Now, let's dive a little deeper into the science behind it all. The formula for kinetic energy is half the mass of the object times the square of its velocity. That might seem a bit complex, but all it's really saying is that kinetic energy depends on both how fast something is moving and how much it weighs. Kinetic energy doesn't just stay as kinetic energy, though. It can be transformed into other forms of energy, like potential energy. Think of a roller coaster. As it climbs to the top of a hill, it's building up potential energy. When it starts to descend, that potential energy is converted into kinetic energy, making the roller coaster zoom down the hill at thrilling speeds. Okay, let's put our newfound knowledge to the test. Here's a quick quiz. Question 1. If a bicycle and a car are moving at the same speed, which one has more kinetic energy? The answer is the car, because it weighs more. Question 2. If a small and a large ball are rolling at the same speed, which one has more kinetic energy? The answer is the larger ball, because its greater mass gives it more kinetic energy. Question 3. What happens to the kinetic energy of a roller coaster when it begins its descent from the top of a hill? The answer is that it increases because the potential energy stored at the top of the hill is converted into kinetic energy as the roller coaster descends. So, there you have it. A quick tour of the world of kinetic energy. It's not just a concept in a science book. It's a real, tangible force that's at work in our everyday lives, from the cars on the street to the roller coasters at the amusement park. Understanding kinetic energy helps us understand the world around us a little bit better. So the next time you see something moving, remember it's not just motion, it's kinetic energy.